Good afternoon, all. I'm Amit Kumar Shinde. I welcome you all for this today's session. In this today's session, we are going to discuss the classification of the tool steels, how these tool steels are classified in different types. Basically, these tool steels, we are using these tool steels for working operation. In this working operation, it may be cold working operation or it may be a hot working operation when we can do the shaping and different cutting operations of the metals with the help of these tool steels. Okay, now here large number of these steels are available here in this tool steel category, and with the these are classified and designated with the help of AISI standards. Okay, now what is this AISI stands for? American Iron and Steel Institute. Okay, this classification, which is visible to you on your screen, this classification is based on AISI standards, that is American Iron and Steel Institute, and these tool steels are classified depending on their purpose or their applications or some special characteristics, as cold work tool steels, hot work tool steels, high speed tool steels, and special purpose tool steels. Okay, now one by one we are going to discuss this. We will start with the cold work tool steels. Okay, uh, if now before actually starting this uh, what is this cold work tool steel, hot work tool steel, high speed tool steels, and special purpose tool steels, here first we are going to discuss some general characteristics of tool steels. Generally, these tool steels are, or which are the desired properties in these tool steels? These tool steels should be hard in nature, then they should have toughness, and they should have very good wear resistance. Okay, so these are required characteristics. Now, depending on our use or the service conditions where we are going to use these tool steels, their characteristics you can change as per your requirement. But general characteristics which we are expecting will be like this: these tool steels should provide high toughness, and then high hardness and high wear resistance. Along with this, they should be very good in the characteristics of, means you can give the desired shape and styles to that tool steels, means they should have should be machinable and grindable. And another important characteristic should be tendency of the decarbonization, or tendency of the oxidation, or tendency of the grain coercion should be minimum. Okay, it should be minimum so that we can do the different heat treatment processes, and depending on that treatment processes we will get the desired characteristics. Okay, now these are some optimum characteristics. Okay, optimum characteristics or values which are required in the tool steels will be like this. I will summarize it. It should have very good hardness, toughness, wear resistance, and they should be easily machinable and grindable. Along with that, they should be there should be minimum decarbonization, oxidation, and grain coercion during the heat treatment process. So these are some general expectations or general properties that we require as we can use that particular steel for as a tool steel. Okay, now depending on their applications or their specific characteristics, they are classified in these four categories with the help of American Iron and Steel Institute, that is AISI, as cold work tool steel, hot work tool steel, high speed tool steel, and special purpose tool steel. Now, first we will discuss cold work tool steel. Okay, now these cold work tool steels, these are generally used for cold working of the metals. Okay, and hot work tool steels are used for hot working of the metals. Now here the basic condition or basic concept here you have to understand is what is the meaning of cold working operation and what is the meaning of hot working operation. The cold working operation or cold working processes, these are the processes, manufacturing processes, uh, which we are conducting below recrystallization temperature of the material, below recrystallization temperature of the material. Okay, that operations will be termed as cold working operations, and the operations which we are conducting above recrystallization temperature and just below the melting point of that particular metal or alloy, that operations are termed as hot working operations. Okay, then to perform cold working operations we are using some special categorized tools, and they are known as cold worked tool steels. Now, some examples of the operations will be like this cold working operations, like you can say that cold rolling, then cold drawing, cold extrusion, bending operation, squeezing operation, coining operation, sizing operation. These all are cold working operations. Okay, operations or processes which we are performing below recrystallization temperature of that particular metal or alloy, that will be termed as cold working operations or processes, and tools used for performing that will be termed as cold worked tool steels. Okay, tools are made up of with the help of these cold work tool steels. And there are some hot working operations. The hot working operations or processes are those processes which we are conducting above recrystallization temperature of the metal or alloy and just below melting point of that particular metal or alloy. And specific tools used for performing that hot working operations will be termed as uh, hot working tool steels. Okay. Now, examples of the hot working operations will be forging, then hot rolling, hot extrusion, then piercing, spinning, or hot drawing, or sometimes some welding operations, breezing operations. It will come under the hot working operations categories. Okay, so specific tools used for these specific operations will be categorized under the cold worked tool steel and hot worked tool steel. Okay, now, here one question will be in your mind, what is the meaning of recrystallization temperature? Okay, depending on working conditions, where we are working, whether we are working above recrystallization temperature or below recrystallization temperature, we have classified these processes as cold working operation and hot working operation. But what is the meaning of recrystallization temperature? Recrystallization temperature is that temperature at which, okay, temperature at which the structure of a particular metal or an alloy uh, is reoriented or reorganized. Okay, reoriented or reorganized, in simple word, it changes. Okay, it changes, and due to this change, that particular metal or alloy becomes more workable or more ductile. Okay, so this is the recrystallization temperature. In other words, simple words, the formation of temperature at which old grain breaks and formation of new grains will start. It will be termed as a recrystallization temperature. And processes which are conducted below this recrystallization temperature are cold working processes. And if you are conducting the processes above this recrystallization temperature, then that processes will be termed as hot working processes. And the tool used for cold working operations will be termed as cold working tools, or tool used for hot working operations. These tools will be termed as hot working tools. And the specific skill category used for this will be categorized as cold working tool steel and hot working tool steel. Okay. Now we will discuss the cold work tool steels in brief. Now, these are generally used for cold working operations of the metals, and these are categorized in four types. Cold worked tool steels are classified in four different types as water hardening tool steel, air hardening tool steel, oil hardening tool steel, and high carbon high chromium steels. And how, on which basis this classification is done? This classification is done depending on their hardening characteristics. Okay, depending on their hardening characteristics, cold work tool steels are classified in four different types as water hardening tool steel, air hardening tool steel, oil hardening tool steel, and high carbon, high chromium steels. Now, one by one, we will discuss this with the help of this next slide. Okay. Now, in this slide, I have highlighted here some specific characteristics of cold work tool steels and their classification. Now, these cold work tool steels generally already I have explained it. These are used for cold working of the metals. Then all these four subgroups or subtypes of these cold work tool steels have this common characteristics or properties, that is, they have good hardness, toughness, and wear resistance at low temperatures. Okay, they are having good hardness, wear resistance, and toughness at low temperatures. Okay, and generally related to their composition, these are okay. These are high carbon steels or medium carbon steels with very small amount of the alloying elements, or sometimes no alloying elements may be there. Okay, so generally these cold work tool steels have good hardness, toughness, and wear resistance at low temperatures. And these steels are either high carbon steels with a very small amount of alloying element or no amount of alloying elements. And hence, as alloying element percentage is very less, these cold work tool steels are less expensive, or these are cheaply available. Okay, now we will move towards the classification. These steels are classified in four different types depending on the hardening characteristics, as water hardening tool steel, oil hardening tool steel, and air hardening tool steel. And last type is high carbon, high chromium steels. Okay, now this water hardening tool steels, these are hardened by the water quenching. Okay, these steels are hardened, or hardening of these steels is done by water quenching. Hence, these are termed as water hardening tool steels, and these are denoted by W series. Okay, W series. Then the hardening of the some steels or tool steels is done with the help of oil quenching. Hence, these are named as oil hardening tool steels, and these are denoted by O series. Okay, this O stands for oil. This W stands for water. The medium used for the quenching to get the desired hardening effect. Okay. Now the third, here we are doing the hardening in the air medium. Hence these steels are termed as air hardening tool steels. Hence, and it is denoted by A series. And the last type is high carbon and high chromium steel. It contains carbon within the range 1.5% to 2%. Sometimes carbon percentage may be more than 2%, okay, 2.2 or 2.3% also, with addition of high amount of chromium and some other alloying elements like tungsten, molybdenum. Okay, one by one, I am going to explain it. And here, as this high carbon, high chromium steels are hardened with the help of two mediums, you can do the uh, or you can do the quenching here with the help of oil or air medium. Hence, these are designated by D series. Okay, you can either go for oil or go for air medium for quenching to get the desired hardening effect. Hence, these are denoted by this D series. Okay, dual mediums you can use. See, name is given as a D series. Now, one by one, we are going to discuss these four types of cold work tool steels with their specific composition, some specific properties, and specific applications. Now, so this is the okay. So this is water hardening tool steel. Now, related to it is before starting its composition, properties, and applications, I will explain again that the hardening of this steel is done with the help of water quenching. Hence, these are termed as water hardening tool steels and designated by W series or denoted by W series. Now, generally, these are plain carbon steels with very high percentage of carbon in the range 0.6% to 1.4%, and a very small amount of alloying element will be there. Okay, this is the composition. High carbon steels with 0.6 to 1.4% carbon and small amount of the alloying element. Okay, now in this water hardening tool steels, sometimes you can go for the low carbon content, means zero point 0.6, or sometimes you can go for the higher carbon content, that is the higher range, 1.3 or 1.4. Now how to decide this range? Okay, now whenever your working conditions requires good impact characteristics or good shock loading characteristics, then you should go for lower carbon percentage. And if in your applications you require high wear resistance or maintenance of the sharp cutting edges is necessary, then at that time you should go for higher carbon percentage. Okay, depending on your applications, here for water hardening tool steels you can go for low carbon percentage or you can go for high carbon percentage. Whenever you require in your that particular tool, if you require very good shock resistance or very good impact characteristics, then you should prefer the low carbon percentage, that is 0.6 or 0.7% carbon with addition of some other alloying elements. And if in your application you require higher wear resistance or very good cutting ability, at that time you should go for high carbon percentage with small amount of other alloying elements. So these kinds of changes may be done depending on your need or your applications in this water hardening tool steels. Now, as already I have mentioned, hardening is done with water quenching. These are termed as water hardening tool steels. Then the general characteristics or properties will be like this. They will provide or they have very good hardness, toughness, and wear resistance at low temperatures. Okay, all code work tool steels will provide you good hardness, toughness, and wear resistance, but at lower temperature ranges. Okay, so these are the properties. These are common properties for water hardening, oil hardening, air hardening tool steels. Okay, some properties may get added depending on some composition change. Now, applications of these water hardening tool steels will be like this. These water hardening tool steels can be used for manufacturing of blanking dies and threading dies, then tube drawing dies, some kinds of drills, some forming tools, some kinds of the hammers, chisels, then woodworking tools which we are using in the carpentry shop. That tools will be manufactured with the help of these water hardening tool steels. Then different kinds of shear blades, knives and razors. Okay, different kinds of knives we are using, that knives and razors, all these are manufactured with the help of water hardening tool steels. Okay, now these water hardening tool steels are having less cost or they are very cheap, and they are having certain limitations also. Okay, in this water hardening tool steels they have some limitations, and these limitations will be like this. Their red hardness and strength at elevated temperature is poor. Okay, red hardness is nothing but if suppose you have heat a particular metal or alloy, when it becomes red in color, and if you check its hardness at that time, that hardness will be termed as a red hardness. Okay, and particularly this water hardening tool steels, it has very low red hardness, then it has very low strength at elevated temperatures. Why this is happening? Because when you are heating it, these water hardening tool steels, becomes soft in nature at higher temperature ranges. Okay, hence you cannot use these two steels. Okay, whenever you are using these hot water hardening tool steels at higher temperature ranges, they what will happen, they temper rapidly and become soft in nature. Okay, soft in nature, and their hardness and strength will be very poor at the higher temperature ranges. Hence we cannot use these water hardening tool steels for performing cutting operations or hot working operations. Okay, this is the reason behind it, because at higher temperature ranges, these cold worked tool steel will become soft. They will lose their hardness and strength and become soft. Hence we cannot use them as a tool. Okay, and one more disadvantage is that whenever you are using these steels at higher temperature ranges, then what will happen, decarbonization will take place. Decarbonization is nothing but loss of carbon. Okay, loss of carbon will occur at higher temperature ranges, and then oxidation will occur when this material will come in contact elements present in these steels like carbon, it will come in contact with oxygen, and carbon dioxide will be manufactured. Like this, oxidation will occur, and sometimes grain coarsening will occur at higher temperature ranges. Hence we cannot use them for conducting any heat treatment process, or we cannot use them for higher temperature applications. So these are the reasons why we cannot use these cold worked tool steels, or specifically this water hardening tool steels. We cannot use them to conduct or perform any heat treatment on it, because whenever we are conducting any heat treatment, we are going to use the higher temperature ranges, and in that higher temperature ranges, oxidation may take place, or sometimes decarbonization will occur, and grain coarsening will occur. And another effect is these tools will become soft in nature, and they loses their strength and hardness also. Okay, so these are the reasons behind why we cannot use these steels for performing hot working operations. And to eliminate these drawbacks which are present in this water hardening tool steels, okay, these are the drawbacks. And to eliminate these drawbacks, uh, we are going to add some other alloying elements like tungsten, molybdenum, chromium. Okay, so that its hardness will get improved. Okay, this is the remedy. These are limitations. Okay, 2 3 limitations I have explained, and to overcome from these limitations in this water hardening tool steels, what we are going to do, we are going to add chromium, vanadium, or molybdenum in small amount. Okay, so that these drawbacks will get eliminated. So these are water hardening tool steels, and we will move towards the second type of cold worked tool steel, and it is oil hardening. Okay, oil hardening tool steel, and this oil hardening tool steel is designated or denoted by O series. Okay, come to the second point here. Hardening of these steels is done by oil quenching, hence the name is given as oil hardening tool steel, and these are denoted by O series. And then these steels have some common characteristics. That is, these steels have good hardness, good toughness, and good wear resistance. And another specific characteristics in this particular oil hardening tool steel is during the hardening process, distortion is very less. Distortion is very less. Hence, these steels are also termed as oil hardening non-shrinkage tool steels. Okay, this is in bracket I have written here OHNS. Oil hardening tool steels are also termed as OHNS, that is oil hardening non-shrinkage tool steels. Why these are termed as non-shrinkage tool steels? Because distortion is very less. Okay. Now related to this, their composition. Okay, in chat box I have received one query. What is the quenching? Okay, quenching is nothing but during the hardening heat treatment process, we are heating that particular metal or alloy in the higher temperature ranges. It may depending on the metal or that alloy. And after heating it in the furnace, we are collecting it and we are cooling it. Okay, we are cooling it with the help of air, oil, or water medium. And this direct cooling method used is termed as quenching to get the desired hardening effect. Okay, this is termed as the quenching. This is termed as quenching. Okay. Okay, now I will come towards this oil hardening tool steel. Okay, this hardening here is done with the help of oil quenching. Okay, and hence the name is given as oil hardening tool steel. And these steels have very good toughness, hardness, and wear resistance, and very less distortion. Hence these are also termed as oil hardening non-shrinkage steels. Okay, OHNS, oil hardening non-shrinkage steels. Now related to their composition, these steels are high carbon steels with addition of some alloying elements. Okay, alloying elements like tungsten, manganese, chromium, molybdenum, vanadium. And here percentage of alloying element is less than 5%. Okay, high carbon steel with small amount of alloying elements like tungsten, manganese, chromium, molybdenum, and vanadium, and togetherly their percentage, okay, percentage is less than 5%. Okay, and some examples I have highlighted here. Okay, 0.9% carbon along with 1.6% manganese. Then second example I have added. If possible, you can write these examples, or this much is also sufficient. Okay, that is high carbon steel with small amount of alloying elements like tungsten, manganese, chromium, and their percentage is less than 5%. Alloying element percentage is less than 5%. And these are some examples. Second example is 1.1% carbon, 0.95% manganese, 0.5% tungsten, 0.75% chromium, and 0.2% vanadium. Okay, these are some examples. Okay, now related to their applications, these steels, oil hardening tool steels, these are used for manufacturing of different kinds of the dies like blanking dies, forming dies, then different kinds of the tools like shear blades, master tools, cutting tools, or different types of gauges. So these are applications of oil hardening tool steels. And then we will move towards the next type of cold work tool steel, that is air hardening tool steels. Okay, now these cold work tool steels are hardened by using air medium. Hence the name is given as air hardening tool steels, and these are denoted or designated by A series. And their general characteristics will be like this. They will have, or they have good toughness, hardness, and wear resistance. And related to their composition, these are high carbon steels along with some alloying elements like tungsten, manganese, chromium, molybdenum. Composition is very much similar to oil hardening tool steel. Then what is the difference in the composition? Here the percentage of alloying element is more than 5%. In oil hardening tool steel, percentage of other alloying elements like tungsten, manganese, chromium, molybdenum, vanadium is less than 5%. And in air hardening tool steel, percentage of alloying element is more than 5%. As the alloying element percentage exceeds 5%, the hardening characteristics or hardenability of these air hardening tool steel is better as compared to oil hardening tool steel and water hardening tool steels. Okay. Hardening characteristic is better, and if you compare water hardening, oil hardening, and air hardening, okay, as we are moving from water, oil, and air, their hardenability will increase, their distortion will decrease, okay, and their wear resistance characteristics, hardness characteristics will improve as we are moving from water hardening tool steel towards oil hardening, and from oil to air hardening tool steels. Air hardening tool steels will have better hardening characteristics, and they will have high wear resistance with less distortion. Okay, so these are some statements related to their characteristics. Then we will move towards the applications. These air hardening tool steels, which are denoted by A series, these are used for manufacturing of different kinds of dies, which we are using in thread rolling or slitting operations. Okay, that is thread rolling dies or slitting dies, then drawing dies, or to manufacture the intricate die shapes or different kinds of gauges and punches. All these are manufactured with the help of these air hardening tool steels. Okay, then the last type in this cold work tool steel is high carbon, high chromium steels. Okay, these high carbon, high chromium steels are also termed as HCHC steels, and this series is denoted or designated by D series. Okay, this HCHC steels stands for high carbon and high chromium steels. Okay, now here these HCHC steels, they have high hardenability. Okay, they have high hardenability. Why they are having high hardenability? Because they contains high carbon percentage. Okay, from 1.5% up to 2.2% or 2.3% carbon may be there. And in addition to this high carbon percentage, chromium percentage is about 12%. And in addition to this, other alloying elements like tungsten, vanadium, molybdenum may be there. Hence, these HCHC steels, they have high hardenability, and their hardening can be easily done, and you can go for oil medium or air medium to do their hardening, or you can say that hardening can be done with the help of oil or air quenching. Related to their composition, I will explain it again. These steels are high carbon steels with 1.5% carbon up to 2.2 or 2.3% carbon, with 12% chromium. Along with that, small amount of other alloying elements like this tungsten, tungsten, molybdenum, and vanadium. V stands for vanadium may present. Okay, due to this composition, you can do the hardening with the help of oil quenching or air quenching very easily. Okay, so these HCHC steels has high hardenability with very less distortion during the hardening, and at the end, whichever hardness is obtained will be very high. That is, they have very high hardness and very high wear resistance. Why this high hardness and wear resistance is there? Because here chromium is present in high percentage or high quantity. This chromium will combine with the carbon and it will form its respective carbide. Then other alloying elements like this tungsten, vanadium, molybdenum, All these alloying elements, they form their respective carbides, and these carbides have high hardness and high wear resistance. Hence, these steels will give you high hardness and wear resistance due to formation of different complex carbides. Okay, so the main characteristics here is high hardness and high wear resistance due to presence of complex carbides, and they provide these high hardness characteristics up to a temperature range of 500 degrees Celsius. Hence, we can use these SCHC steels for different applications, like in manufacturing of drawing dies, blanking dies, and forming dies, coining dies can be manufactured, then different kinds of thread rolling dies, trimming dies, different kinds of the bushings, and different kinds of shear blades, punches, different kinds of tools used for cold forming, then different kinds of cutting tools and gauges can be manufactured with the help of this HCHC steels, or high carbon high chromium steels, or the cold worked tool steels from this D series. Okay, sometimes some questions may be there, like uh, as these steels, HCHC steels, has carbon percentage more than 2%, then why we are not considering it as a cast iron? Okay, carbon percentage is more than 2% also in some cases, but still we are considering it in the category of steel only. Why we are not considering it as a cast iron? These type of questions may be there in quantitative examinations. Okay, so a proper answer for it, there are two reasons. Okay, two reasons for it. Whenever you are categorizing any iron alloy in cast iron, it should show you eutectic transformation. We have studied that in iron iron carbide diagram, that cast iron shows eutectic transformations. Okay, eutectic transformation must occur in any kind of cast iron. But these HCHC steels, here eutectic transformation does not occur. This is the first reason. And second reason, whichever higher percentage of carbon is there, more than 2%, whichever extra carbon is there, that extra carbon combines with the alloying elements like chromium, tungsten, vanadium, molybdenum, and they form their respective carbides. Okay, whichever higher percentage or extra carbon is there, more than 2% carbon, suppose 2.3% is there, then that 0.3% carbon will combine with the alloying elements like chromium, tungsten, vanadium, or molybdenum, and they will form their respective carbides. Hence, the net carbon percentage will be less than 2%, and it will remain in the form of a solid solution with iron as a austenite phase only. Okay, so these are two reasons that these steels, SCHC steels, have higher carbon percentage, but still they are considered as steel. Now we are not considering them as a cast iron. That is, they does not show you tectic transformation. And second reason, whichever higher percentage of carbon is there, it combines with the other alloying elements like chromium, tungsten, molybdenum, or vanadium to form their respective carbides. Hence, the net carbon percentage in HCHC steel remains approximately 2% only, about 2% only. Okay, so there is some more information. The last three types, okay, from this cold worked tool steel, I will highlight that in the slide. These last three types, oil hardening tool steel, air hardening tool steel, and high carbon high chromium steels, all these three tool steels shows very less distortion, very less distortion during their hardening. Very less distortion will be there. Hence, these three steels, okay, these three categories B, C, D, that is oil hardening, air hardening, and high carbon, high chromium steels, are termed as non-deforming tool steels or non-shrinkage tool steels. Okay, these three categories. As during their hardening process, distortion is very less. These steels are termed as non-deforming or non-shrinkage tool steels. Okay, oil hardening, air hardening, and HCHC steels are termed as non-shrinkage tool steels or non-deforming tool steels because during hardening, very less distortion occurs. Okay, so in this way, we have completed the four types of cold worked tool steels, like water hardening tool steel, oil hardening tool steel, air hardening tool steel, and HCHC steels, along with their composition properties and applications. Now we will move towards next type, and that is hot work tool steels. Okay. Hot work tool steels. Okay, hot worked tool steels. These are the steels which are used for hot working of the metals. Okay, hot working of the metals means the working of the metals above their recrystallization temperature and just below their melting point. And the examples of these operations are like stamping operation, drawing operation, piercing, or extrusion, or forming, upsetting, or swagging. These are different hot working operations. Okay, and tools used for performing these hot working of these hot working operations of the metals are termed as hot work tool steels. Tools that material used for that is hot worked tool steel. Okay, now the general characteristics of these hot work tool steel will be like this. They have good strength, toughness, and hardness, along with very good wear resistance at elevated temperatures or at higher temperatures. Okay, same characteristics are there in cold work tool steel, but they are not providing these characteristics at higher temperature ranges. Now, hot work tool steel will provide you good strength, toughness, hardness, and wear resistance at elevated temperatures or higher temperatures also. Okay, why they are able to provide these properties? Because they will provide you excellent resistance to tempering or softening at elevated temperatures or higher temperatures. Okay, at higher temperatures also they will give you hardness. They does not become soft because tempering does not takes place here or does not occurs here. Hence they will remain hard and provide a very good wear resistance at higher temperatures also. Then depending on uh, the percentage of alloying elements, they are classified in three types. But generally here, whichever hot work tool steels are there, generally they are medium carbon steels with low amount of alloying element percentage or high amount of alloying element percentage. Okay, medium carbon steels with low amount or high amount of alloying element percentage. And as alloying elements are distinguishing them depending on the presence of major alloying element or principal alloying element, these hot working tool steels or hot worked tool steels are classified in three different types as chromium type tool steel. Here chromium is principal alloying element. And when tungsten is principal alloying element, then that hot work tool steels are termed as tungsten type tool steels. And when molybdenum is principal alloying element, then that hot work tool steel is termed as molybdenum type tool steel. Okay, one by one, we will discuss all these three types along with their composition, properties, and specific applications. Okay, now this is the first type of hot work tool steels, this chromium type tool steel. Now, generally it is a medium carbon steel, and carbon percentage or carbon content lies in the range 0.35% to 0.65% with principal alloying element as chromium, and this chromium is present in the range of 3% to 7%. And in addition to this carbon chromium, some small amount of other alloying elements like tungsten, molybdenum, or vanadium may be there. So this is the composition of chromium type tool steel. Then related to their characteristics or properties, okay, these steels will show you high ductility and high toughness, and due to presence of the chromium as a principal alloying element, they will provide you very good resistance to the splitting. Okay, splitting resistance to splitting is nothing but resistance to the tearing. Due to application of some load, material may get removed from the, okay, metal may get removed from your workpiece. Okay, and whenever resistance to this splitting or tear is high, removal of material does not occur from that metal or alloy, and that property is present in this chromium type tool steel, and it is termed as resistance to splitting or resistance to tearing. Due to application of load, material may get removed, and resistance provided to this will be termed as resistance to tearing or a resistance to splitting. So these are some properties of this chromium type tool steel. Chromium type tool steels have high ductility, high toughness, and very good resistance to splitting. Then related to the applications, these steels are used for manufacturing of, okay, some die casting sorry, some casting dies are manufactured with the help of these chromium type tool steels, and specifically here we are using these steels for manufacturing of aluminum and magnesium die casting dies. Okay, then other applications, these chromium type tool steels are used for manufacturing of extrusion dies, forging dies, mandrels, and hot shears. Okay, so these are different applications of chromium type tool steel. Then we will move towards the second type of hot work tool steel as a tungsten type tool steel. Okay, hot work tool steels in which tungsten is present as a principal alloying element will be termed as tungsten type tool steel, and their approximate composition will be like this. Carbon percentage will be in the range 0.3 to 0.5%. The tungsten quantity will be in the range 9% to 18%, and in addition to this, chromium will be there, and its percentage will be from 2 to 12%, and in addition to this, very small amount of molybdenum and vanadium may be there. Okay, principal alloying element is tungsten. Chromium is also there, and its range will be 2 to 12%. Related to their properties, as here we are having tungsten in very large amount, these tungsten type tool steel will provide you excellent, or these tool steels will provide excellent red hardness and excellent wear resistance even at elevated temperatures or higher temperatures. Okay, and these are the specific characteristics of these tungsten type tool steels. And related to their applications, tungsten type tool steels are used for manufacturing of dummy blocks, then forging dies, and hot punches. These tungsten type tool steels are also used for manufacturing of hot extrusion dies, which we are using for different kinds of brass, then nickel alloys and steels. Okay, so these are applications of tungsten type tool steels. And third type of hot work tool steel is molybdenum type tool steel. Now here molybdenum will be principal alloying element. Its approximate composition will be like this. Carbon percentage will be in the range 0.55% to 0.65%, and molybdenum, chromium, vanadium, and tungsten togetherly it will be in the range 14 to 20%. And out of these four elements, molybdenum will present in the largest quantity. Hence, this type is termed as molybdenum type tool steel. Then their specific characteristics of this molybdenum type tool steels will be like this. These molybdenum type tool steels, they have very good shock resistance. Okay, then their wear resistance will be very good under normal working conditions or normal temperatures. Then they will provide you high strength. They also exhibit high strength at elevated temperature or higher temperatures also, and their toughness will be more at higher temperature also, and resistance for tempering is very high. So these are some characteristics or properties of molybdenum type tool steels. Due to these characteristics, these molybdenum type tool steels are used for manufacturing of okay, different die castings. Then the die is used for forgings, then extrusions, then piercings, trimming purposes, then different kinds of punching blades or shear blades, hot shear blades. All these can be manufactured with the help of this molybdenum type tool steels. Okay. Then after discussing these three types of hot worked tool steels, we will move towards the third type of tool steel, that is high speed tool steels. Okay, high speed tool steels, these are designated by H cells. Okay, why these steels are termed as high speed tool steels? Due to their some characteristics. Now I will explain it. If you have any query related to first two types, that is cold work tool steels and hot work tool steels, or any query related to their subtypes, please mention that in the chat box. I will answer them. Now I will explain this high speed tool steels. Okay, why these tool steels are termed as high speed tool steels? Now these steels maintain their high hardness up to a higher temperature, about 550 degrees Celsius. Okay, hence you can use these steels for performing cutting operations with very high speed. That's why these tool steels are termed as high speed tool steels. In short, we can say that HSS. Okay, high speed steels or high speed tool steels. Why we are giving them this word? Because you can perform the cutting operation at very high speed. And why we are able to perform cutting operation at high speed? They will maintain their high hardness even at higher temperatures of about 550 degrees Celsius also. Okay. Then they are related to their properties. They have high wear resistance and high cutting ability. Okay. These are their special characteristics. These high speed tool steels have high wear resistance and high cutting ability. Now, These tool steels or these high speed tool steels are classified in two types as tungsten type. Okay. Now these high speed tool steels are classified. These are classified in two types or two different subgroups as tungsten as tungsten high speed tool steels and molybdenum type high speed tool steels, depending on the presence of principal alloying element. Okay. Now these tungsten type high speed tool steels are denoted by T series or W series, and molybdenum type high speed tool steels are denoted by M series. Now we will discuss them one by one. Okay, tungsten type high speed tool steels, they contain high amount of tungsten with other alloying element also. Okay, they contain high amount of tungsten with other alloying elements like chromium, vanadium, or cobalt. These are designated by T series. These high speed tool steels are designated by T series or W series. And for example, here I have highlighted one high speed tool steel grade T1, which contains 0.7% carbon, 18% tungsten, 4% chromium, and 1% vanadium. This is one example. Okay, you can give the composition like this: high carbon steels with high amount of tungsten and very small quantity of other alloying elements like chromium, vanadium, and cobalt, and these are denoted by T series or W series. Then related to their properties, these steel maintain high hardness even at higher temperature ranges of about 550 degrees Celsius. And second characteristics or properties will be like this: they have very good or very high wear resistance and very good cutting ability. In related to the application point, as far as applications are concerned, tungsten type high speed tool steels are used for manufacturing of different types of drills, taps, reamers, milling cutters, saws, and different lathe tools, different kinds of punches, different drawing dies, and woodworking tools. And we will move towards the second type of high speed tool steels, like molybdenum type high speed tool steels. These are related to their composition. These are high carbon steels with very high amount of molybdenum with other alloying elements like tungsten, chromium, vanadium, and cobalt. These are designated by M series, and one example directly you can write M2 here. If then they're related to composition of this M2 grade steel. It contains 0.85% carbon, 5% molybdenum, 6% tungsten, 4% chromium, and 2% vanadium. Then these steels properties will be same. Properties will be same for tungsten type and molybdenum type high speed tool steel. These steel have high hardness at higher temperature ranges also, and they have very high wear resistance and cutting ability. Applications will be same also. These molybdenum type high speed tool steels or M series tool steels are used for manufacturing of different kinds of drills, taps, reamers, then milling cutters, saws, lathe tools, punches, different kinds of the drawing dies, and different woodworking tools which we are using in the carpentry shop. Okay, so and related to the comparison of these two high speed tool steel, and the molybdenum type tool steels, high speed tool steels, these are less expensive or cheap in nature, and they have more tendency of oxidation, decarbonization, or grain coercioning. Okay, molybdenum type high speed tool steels, these are less expensive, their strength is also less, and they will undergo or they will show more oxidation, decarbonization, and grain coercioning during the heat treatment process as compared to tungsten type high speed tool steels. Okay, so these are two types of high speed tool steels. Now, related to this alloying elements. Okay, now here one more concept or one more specific type of high speed steel is there, that is super high speed steel. Okay, super high speed steel is a steel which contains 5% vanadium. Okay, super high speed steel. This is just for your information. I am telling you, super high speed steel contains 5% vanadium, and due to this 5% vanadium, it will result in the formation of its respective carbides by combining with the carbon, and it will give you highest hardness up to 70 or 72 RC, that is hardness measured with the help of Rockwell hardness tester. Okay, as compared to the hardness provided by other types of high speed tool steels, other types of high speed tool steels, that is molybdenum type or tungsten type, will provide you hardness 65 to 66, but these super high speed steels will provide you 70 to 72 hardness value, uh, as it contains 5% vanadium. Okay, so after this high speed tool steels, the last type of tool steels. Okay, all remaining types of the tool steels are categorized under this special purpose tool steels, depending on their specific composition or properties or their specific applications. And under this special purpose tool steels, we have four types of tool steels. The first type in that is shock resisting tool steel, that is S series, and its composition will be like this. It contains 0.5% carbon and one or more alloying elements like manganese, chromium, tungsten, molybdenum, vanadium, and silicon. Okay, now related to these properties, as name itself indicates, due to presence of silicon and molybdenum, it has a very high shock resistance, and along with that it also provides required strength and toughness, and due to presence of other alloying elements, they form their respective carbides, and it results in high hardness and high wear resistance at higher temperature ranges also. And due to these characteristics, these shock resisting tool steels or S series tool steels are used for manufacturing of different kinds of punches, chisels, concrete breakers, then rivet sets, forming dies, and shear blades. Okay, these are shock resisting tool steels. Then second type under this special purpose tool steel is low alloy tool steel, which is designated or denoted by L series. And here its composition will be like this. It contains 0.6% to 1.4% carbon, with chromium as their principal alloying element, and related to their properties, this low alloy tool steel has very good, due to the presence of this chromium and high carbon percentage, their wear resistance is very high and very good toughness and hardness. And these steels are used for manufacturing of different machine parts like arbors, chucks, cams, or collets. And these steels we can use where high resistance or toughness is required. Okay, these are property composition properties and applications of low alloy tool steels denoted by L series. Then carbon tungsten tool steel, which are denoted by F series. Here, these carbon tungsten tool steels are nothing but high carbon steels with more than 1% carbon percentage, along with tungsten as a principal alloying element. Okay, with more than 1% as a tungsten as a principal alloying element, and due to presence of this tungsten and high carbon percentage, due to presence of their respective tungsten will form their its respective carbide. These carbon tungsten tool steels will provide high wear resistance and abrasion resistance, along with very good toughness and hardness. Hence, these carbon tungsten tool steels or F series tool steels can be used for manufacturing of different kinds of tools like broaches, reamers, taps, or burnishing tools. Then the last type from this tool steel category is mold tool steels, which are denoted by P series. Okay, and from how to remember this mold tool steels, these are used for manufacturing of the plastic molds. And as in the plastic mold, we require high hardness on the surface and a very good strength or tough core, very tough core uh, to absorb the shocks during the compression cycle. Hence, these steels have high surface hardness and very tough core, along with very good shock resistance ability. Their composition will be like this. These are as very high shock resistance ability is required. These are low carbon steels. Max carbon percentage is up to 0.2%, and along with some other alloying elements like chromium and nickel. And specifically, these mold tool steels are used for manufacturing of different kinds of the plastic molds. Okay, so in this way, we have completed this tool steels, and in this tool steels, we have completed cold worked tool steel with its four types: water hardening tool steel, or oil hardening tool steels, air hardening tool steels, and high carbon high chromium steels. Then hot working tool steels with its three types: tungsten type, molybdenum type, and chromium type hot work tool steels. Then after that, we have completed high speed tool steels with its two types, like tungsten type high speed tool steel and molybdenum type high speed tool steels, and special purpose tool steels with its four subtypes, like mold tool steels, then shock resisting tool steels, low alloy tool steels, and carbon tungsten tool steels. Okay, now a generalized statement or one conclusion we can make here related to the all tool steels or alloy tool steels, that whenever we require abrasive hardness or high wear resistance or high toughness or red hardness or non-deforming properties, that is less deformation, then we can use these different kinds of the tool steels for that operation. Okay, in this way, in this today's session, uh, I have completed this. Okay, in this today's session, I have completed this tool steel along with their subtypes, with their composition properties and applications. If you are having any difficulty, you can mention that in the chat box. Okay, thank you very much for attending this session. Okay, thank you very much for attending this session. Thank you. Next session, I will add one video related to the stainless steel. What is the meaning of stainless steel and how the stainless steel are classified along with their composition properties and applications. Thank you very much.